Hi students, welcome back to my channel Electronics Express. Today in this video, let us learn about what is meant by self-inductance and its applications. Before going to the self-inductance, first let us learn what is an inductor. Now let us see how we can define an inductor. An inductor is a passive electrical component that opposes the sudden changes in the current. And the inductors are also known as coils or chokes. So if you see here, this is the appearance of the inductor. Now let us see some of the symbolic representations of an inductor. So these are the different symbolic representation of the inductor. The first one is the generic air core inductor. The second is the iron core inductor. The third is the ferrite core inductor. And the fourth one is the variable inductor. So this is how the inductor is used as an electrical component which opposes the sudden changes in the current. Now let us see how we can define the inductance. The inductance is the property of an inductor that opposes any changes in its magnitude or the direction of the current flowing through it. Now let us see the units of the inductance. The unit of the inductance is Henry. So generally the inductance is represented in three different symbols. The first one is the mH, which means millihenry, and the value in the numbers is 10 to the power of minus 3. The second symbol is micro H, which means microhenry, and the value in numbers is 10 to the power of minus 6. The third is NH, which means nanohenry, and the value in numbers is 10 to the power of minus 9. So this is how the inductance of an inductor is calculated. Now let us see how we can define the self-inductance. The self-inductance is the property of the current carrying coil that resists or opposes the change of current flowing through it. So if you see here, this is the current carrying coil which is connected to a battery and a switch. This is the induced EMF across the coil, and these are the magnetic flux lines. Now this current carrying coil will resist or opposes the change of current flowing through it, and that property is called as the self-inductance. Now let us derive the expression for the self-inductance. The induced voltage in an inductor is directly proportional to the rate of change of current, and that is expressed as VL is directly proportional to di by dt, from which we can get VL is equal to minus L into di by dt. Let it be equation 1. Now according to the Faraday's laws of electromagnetic induction, the rate of change of magnetic flux leakage is equal to the induced EMF. So that's why VL is equal to minus N into d phi by dt. Let it be equation 2. Now by equating equation 1 and equation 2, we get minus L di by dt is equal to minus N d phi by dt. Let us cancel this negative sign and differentiate the equation by dt. So we get L into di is equal to N into d phi, from which we get L into I is equal to N phi, from which we get L is equal to N phi by I. But since we know that the expression for magnetic flux phi is equal to mu naught into N by L into I into A, now by substituting this magnetic flux value, we get the final expression for the self-inductance as L is equal to mu naught into N square into A by L. So this is the expression for the self-inductance. Now let us solve a problem related to the self-inductance. The question is, when a current of 2 milliamperes is applied to a coil with 100 turns, then a magnetic flux of magnitude 0.2 Weber is linked with it. Then find the self-inductance of this coil. This is the question. Now let us see the solution. Now according to the given data, we know that the current supplied to the coil I is equal to 2 milliamperes. The number of turns in the coil capital N is equal to 100. And the magnetic flux linked with the coil phi is equal to 0.2 Weber. Now the self-inductance of the coil is given by the equation as L is equal to N phi by I. Now by substituting the values, we get L is equal to 100 into 0.2 by 2. So therefore we get the value of the self-inductance L is equal to 10 Henry. So that's why this coil has a self-inductance of 10 Henry. So this is how we can solve a problem related to the self-inductance. Now let us see what are the applications of this self-inductance. The first application is the transformers. The second one is the filters. The third one is the chokes. The fourth one is the ferrite beads. And the fifth one is the inductors which are used as a relay. So these are some of the important applications of the self-inductance. Now let us see the question of the day. The question is, when the number of turns per unit length of a solenoid is double, then its self-inductance becomes what? That is the question. The first option is 4 times. The second option is 8 times. The third option is doubled. And the fourth option is same. So if you know the answer, comment me the answer in the comment box. So this is the end of the video. Hope you like this video and understand the concept of what is meant by self-inductance and what are the applications of this self-inductance. So if you like this video, please do like, share and subscribe to my channel Electronics Express. Don't forget to click the bell icon. Please subscribe to my channel. So మీకు గనక ఈ వీడియో నచ్చినట్లయితే ప్లీజ్ సబ్స్క్రైబ్ చేసుకోండి.